Hi, Math for Liberal Arts. We're back to some more probability here. So here is the event. So an event is something you do. So the event is rolling a die. So this is a fair experiment, like we looked at before, because there's an equal chance of getting on any one of these die. Now, if you went to Vegas with a loaded die, you might have heard that, where it's going to land on one of these faces more than the others. That would be cheating, and they would probably kick you out, right? And it wouldn't be fair anymore. But if this is a regular die, we can roll it. It's equal chance of getting a 1, 2, 3, 4, 5, or 6. So in event 1, we call these the outcomes. Rolling a 1 is an outcome. Rolling a 2 is an outcome. Rolling a 3, and so on. So we could talk about the probability of that. We could say, what's the probability of rolling like a 2, for instance? Again, we're going to say favorable outcomes here. Well, there's one right there, is 1 out of all 6 of them. Okay? So this would be a probability of 1 to 6. Now, we also are going to talk about odds in favor and odds against. So on this basic, I roll that die, we can know the odds in favor and odds against of something happening. So with one die, the odds in favor of, say, rolling a 2, like we just did, the odds in favor, I want all the things that could happen that are good. Well, there's only one thing that could happen that could give me a 2. And then you do the colon, and you say to all the other outcomes. Okay? So odds against is the exact opposite. So just think of that first word that comes up. Odds against. Okay, what's against it first? So odds against getting a 2 is a 5 to 1 chance. Okay? One tool that we use in probability is these things called tree diagrams. So let's say I wanted to know the probability of rolling 2 dice in a row. So I roll a die, and then I roll another die. Okay, well, that would be event 2, right? So I roll event 1. So let's say I roll the die, and I get a 1. So one die, I get a 1. I pick it up, and I'm going to roll it again, and I need to see what the second event's going to be. Well, these are all the different things that could happen. I could get a 1, I could get a 2, a 3, 4, 5, or 6. We call this thing right here, this is called a tree diagram right here. We take the event, the first event, and we just branch it off. And we just say the first event, all these things could happen after the first event. Okay. Then from there, we have these different things that are outcomes. So I have a 1 and a 1, or I could have got a 1 and a 2, or a 1 and a 3, a 1 and a 4, and so on. So I could continue to do this for every single number, and you can see that these outcomes are going to start to really stack up. So this brings us to our counting rule of probability, which says basically if you have 2 events, you can just multiply the 2 events by how many there are. So if there's 6 things that can happen in the first event, and there's 6 things that can happen in the second event, well, 6 times 6 is 36. So we have 36 possible outcomes when we roll 2 die, okay? And they could be, you just can use the tree diagram to kind of trace what they are. You could get a 6 and then a 2. You could get a 5 and then a 3, okay? So let's say I want to know the probability of getting a 1 and a 1, okay? So I would see that this only happens once. So the probability of this happening is once, but now I want to know, well, how many outcomes are there? Well, I could count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 24, 36, or 30, 36. So there's a total of 36. But again, we can just use that counting rule where if there's 6 things that can happen in event 1, there's 6 things that can happen in event 2. We can multiply them together to get a total of 36 events. So what's the odds in favor of getting this 11 or this 1 and a 1? Well, that only happens in one scenario, and there's 35 other ways that would make it not happen, right? So odds against rolling a 1 and a 1, snake eyes is what they call it in Vegas. The odds against snake eyes, there's 35 ways to get not snake eyes and only 1 to get the snake eyes. Remember, that's the 1-1 outcome right here. Okay? So we can use